Welcome to Security Weekly. I am your host, Matt Alderman. We are recording live from Black Hat 2019. We're in our suite at Mandalay Bay, and I am joined by Peter Smith, the founder and CEO of Edgewise.
That's right. Thanks for having me, Matt.
Thanks for joining us. Now, we've interviewed your folks a couple times on the show. Really love your technology. But we're going to talk about an interesting use case of your technology today, really when it comes to administrative tools. So let's frame up the problem of admin tools, PowerShell, Bash, etc., and where are some of the challenges that you guys see, and then we'll talk about how Edgewise can help solve aspects of those challenges.
Yeah, administrative tools pose a very significant challenge. They tend to have access very broadly because they can do multiple differentiated things. So think about, for instance, a MS SQL database administrative tool. It can connect to a staging system, a dev system. It can connect to a bunch of other things. And what that really represents is administrative tools represent high potential for abuse by attackers, as opposed to fixed function business applications where they really just do one thing. Every time you run Microsoft, Dynamics, it connects to the same database. Doesn't matter how you run it, it just does one thing. Whereas that MS SQL admin tool can do a variety of things. So as an attacker, you want to get your hands on that because you can abuse the access it has.
Yeah, and if we think about where application development's going, right, this concept of DevOps, right, you have a lot of these tools being used by the operations team to deploy software into production or from the development team, et cetera. So, right, so we see a proliferation of some of these administrative type tools deploying code into various test, staging, production environments also.
Yeah, that's the exact reason why Locker Goga is a good example, which was the malware that was used in the Norse Hydro attack. That was really intended to go straight to Active Directory because, as you pointed out, as far as distribution is concerned, it centralizes all of the access. Everything accesses Active Directory, and Active Directory generally has access to everything. SSM would be a great example, Puppet, Chef, Ansible, SaltStack, so on and so forth. All of these tools require the access, and therefore it represents great potential for lateral movement using that access.
Right. So some would say, well, I have an endpoint detection response system, or I have my firewalls in place. I have these other tools. Why are they not as effective in addressing aspects of this challenge?
Yeah, administrative tools are pretty complicated because the difference between what an administrator does and what an attacker does from just a sort of key indicators, they look very similar. How do you disambiguate a PowerShell script that is connecting into an Active Directory domain controller versus the same type of script that's used by an attacker for the same purposes? And a lot of the approaches used today, you would say security groups or next-gen firewalls or even the EDR platforms, they really just don't have the ability to control at the right level. So as an example, Edgewise, we've got a very different approach. You can apply differentiated policy on a per script basis. So for instance, you might have an individual Python script that only needs access to one system. You can apply policy to that individual Python script to give it only the access it requires. Meanwhile, another Python script running right next to it on the exact same system does not have the access. You can do that for PowerShell, Python, even individual Java jars. So it's a very different way of managing access at the script level, at the software level, instead of sort of at the system or IP address level.
Right. So instead of trying to do it at the network layer or at the holistic endpoint layer, you're doing it, I would say, more at the application layer, right?
That's a great way of putting it. Yeah, I could not agree more. It's the software itself that needs the access, therefore give the access to the software.
And this is what makes you guys a little interesting in what you do from a microsegmentation protection perspective, right? It's that that's the granular software application control capabilities that you allow certain apps to talk to other apps, and that's the only thing they can do, right? Which enforces kind of a whitelisting approach, right? When you think about it, is I have said this can talk to this and don't let anything else happen. Where it's not as easy to do that because at the network and the endpoint layer, it requires you to understand behavior across those diverse environments, and that's really, really tough, I think, for most organizations to be able to do,
Yeah.
or a vendor in that case.
Let's take an example. And I'm always reticent to invoke the most recent to breach, so I'm not going to actually say the name, but there was a recent breach
Yes.
where access to the 169.254, 169.254 port 80, which is the AWS metadata service, was required for the Amazon SSM agent. And really, when you allow access to that service through a security group, what you're allowing access to is anything running on that server now has access to the AWS metadata services group. And I think people just don't really think in those terms that when they assign an ACL to an address,
Right.
what they're actually doing is assigning that ACL to anything that runs on that system, and therefore it can access it.
Right.
And our differentiated approach is that you could say that only the Amazon SSM agent is allowed to talk to the AWS metadata service. Nothing else has that access. Nothing else besides that one Java jar is able to access the S3 bucket.
But wasn't the promise of next-gen firewall to be able to do this at the application layer? I'm being a little facetious, but that was the point, right? If I know layer 7 traffic and I know the application that's coming through the firewall, I ought to be able to control that at the application layer.
That's right. That's the promise. That's why they call it application identity. But the reality is that's layer 7 protocol identity. So a great example, and one that we often use, is the MySQL jackpot exploit, which was using user-defined functions in standard MS SQL queries to remotely load a plugin into a MySQL database and exploit it. And the firewalls, we've gone through all of the firewalls to test it, and not a single one of them can actually detect it. They accurately detect that it's MySQL protocol, but that's not the software.
Right.
That has nothing to do with the software. It can't differentiate basic telnet administrative tool from the actual jar that should be connecting from the MySQL jackpot exploit. And that really just sort of emphasizes what the deficiency of protocol inspection. Not to mention which, I think it's worth pointing out that nowadays, everything talks over HTTP or HTTPS, not to mention TLS 1.5, which is going to make introspection of those communications even more difficult. So I think deep packet inspection in general sort of misses the mark on actually controlling what is communicating. It's certainly better than no security at all, but I truly believe that application identity at the software layer is the future.
Yeah, and I always equate this to, as we think about digital transformation, we're going to abstract away the network. We're going to abstract away the endpoint. What's left? It's the application and the people that are accessing the application, right?
I love it.
And so I've always been this big proponent of app user data. Those are the 3 types of security controls that transcend digital transformation. How does that triad become secured better, right? I'm a big fan of identity and the expansion of identity into the application side with service accounts, et cetera. I think better controls around applications, what applications can communicate to, and then obviously at the end of the day, it's all about data protection because that's what everybody's after. They're after the credit card data, the PII, whatever it is. And so what you've done is you've addressed a big portion of the application layer, probably a little bit into the identity, but very important pieces is part of what you call zero trust
identity
microsegmentation.
There's a lot there. So as far as identity is concerned, we really view identity as exactly what you said: the identity of the user, the identity of the device, the identity of the software. And as far as this concept of digital transformation, if you peel everything away and you say, what is access really? What is it? There's 2 things that talk to each other. Software talks to software. Software is controlled by users, whether that's a service account or a person hands that keyboard. And so from my vantage point, assigning policy to software is the key because to your point, it abstracts away all of the how. So a good example of addresses, ports, and protocols, traditional firewalling, that's how things communicate. That says nothing of what is communicating. What is software talking to software controlled by users? That is the world of Edgewise. That is the world of zero trust identity.
And that's the challenge I think everybody's going to have to continue to try to solve in this new world. So I'm listening to this. I, you know, let's talk just quickly about deployment. How
Mm.
does this thing, how does it deploy? What do you need to do to set up Edgewise?
Uh, Coincidentally, we'll use SSM, Active Directory, Puppet Chef, Ansible, SaltStack, whatever configuration management or broad systems management capabilities you use. We'll use those to actually deploy our LSM module and WFP module into your Linux and Windows environments. Now, once we do that, we analyze the environment, we collect all of the identity properties of the communicating software, build this directed graph. It's a visual graph
Mm,
representation of how all things communicate. One of the main differentiators of what we do is that we can actually see through through load balancers. So load balancers are pervasive, right?
hmm
And they stop you from seeing end-to-end communication. We see through that, so you get a perfect topological map of your environment. Then the ML system over approximately 72 hours builds the policy set and gives you one-click automation of
Mm,
deploying those policies into a simulated block state. Once you're confident in those policies, you can switch them from simulated to actually enforced.
wow.
Yeah, so the irony here is that we'll use this broad access from Active Directory and otherwise to get the deployment in place, and then we make sure we secure it so that only the SSM agent can talk to the appropriate Amazon endpoints, or
Right.
in the case of Active Directory, LSAS to LSAS, so on and so forth.
Yeah, got it. So first get that visibility. Where is everything at?
Hmm.
Do a little modeling of understanding kind of what that behavior looks like,
Hmm.
which is tough. Then set up policies to simulate and then eventually block anything that's abnormal or malicious.
Perfect.
Awesome. If people want to get more data or more information, where should they go?
Edgewise.net. It's the place to be.
Awesome. Peter, it was an awesome interview.
Thank you
Thank you
very
very
much.
much. And with that, we'll take a break and see you soon.